Welcome to the beginning of a legendary YouTube channel, Code with Beer. So, this channel, Code with Beer, is dedicated completely to my coding journey, what I do at my work, the projects I work on, and my personal lead code journey, and anything regarding coding and software engineering that you want me to share. I will be updating those things in this YouTube channel. So yeah, that's pretty much it. Let's start uh, our today's session, today's video. So yeah, for today, what I have planned at the beginning of this channel. So I wanted to celebrate with you guys for beginning this channel, and I to celebrate. In order to celebrate, what I thought of is like we are going to solve a problem in lead code, and yeah, so that's it. That's how software engineers celebrate. Yeah, solving lead code problems. So yeah, this is the problem that I have thought of sharing with you guys the solution. So this is a pretty much a very famous problem. I did it a long back, maybe at my college, and now recently I was also trying to solve it again. And like, yeah, I thought of sharing with it uh, with you guys. So yeah, let's begin with that. So it's called generate parentheses. So let's go to the problem once. Given n pair of parentheses, write a function to generate all combinations of well-formed parentheses. So you are given a number n, right? That is the number of pair of parentheses you have at your disposal. So pair means like you will be having two n parentheses in total, n of opening parentheses and n closing parentheses, right? Like that. So yeah, that is it. Let's think about the solution now. Let me write something down here. Yeah. So I hope this is visible. So the input that we have is an integer n, which is number of pair of parentheses. I hope the spelling is correct. Says parentheses. Yeah, it seems correct to me. Oh, I missed the email. Okay, so this is the input for us, and we need and it needs something to be output. Obviously, most problems actually does need an output, right? Some problems sometimes also do not need an output. They just change something, like do some job or something like that. Anyways, here now coming to the output, let me make it a different color. The output is going to be what? An array of strings, right? All strings of character of length 2 into n, right? So so our output would be an array of strings, all strings of length 2n, right? Now, yeah, so and let us define more about the output, not just this, right? This is a part of it. So what are the other characteristics of these strings? The other characteristics of these strings can be like, we can use only parentheses for the string. Yeah, this is one thing. And finally, the string element should represent a valid par. I was again going to spell it wrong, man. Thesis. It's a tough thing, I think. Parenthesis. Yeah. So this is what we got. Now there is one more interesting thing, I think. That is valid. Let me make it a different color. Uh, yeah, red seems good. Yeah. Valid parenthesis. What does this thing mean? Uh, what can we do? It's not looking good. Back. Yeah. Yeah. We are here. So what is a valid parenthesis? What is it? So a valid parenthesis is basically nothing but like imagine a thing like this. So uh, yeah, let us have a like if there is just an opening parenthesis, is it a valid one or not a valid one? It's not a valid one, right? So it's not a valid parenthesis, right? Now let's check again. If suppose we have just an opening parenthesis like this, is it a valid or not a valid? It's not a valid, right? It's not a valid parenthesis. Yeah, this is also not a valid. So the number one thing that we need to focus on right now is the string always has an even length, isn't it? Yeah, because n is always a natural number, like, and the string will always have even length, right? So there will be always more than one parenthesis. Yeah, like that. And the second thing is there should always be equal number of closing and opening parentheses. Okay, yeah. So let's write these points down here. The string will always have same number of open, which is this one, and close parenthesis. Yeah, that's it. So the numbers will always be same. So even if we consider that, let's try with something like some of these kind of test cases. uh, Let me come up with something. Yeah. Hmm. So yeah, is this a valid parenthesis? Yeah, this is right. This is a valid parenthesis. And another example can be, is this a valid parenthesis? It is a valid parenthesis. This is correct. Now think about another example. Is this a valid parenthesis? Yeah, it is not a valid parenthesis, right? So why is it not a valid parenthesis? Because because the number of opening and the closing parentheses are not equal, right? So let's write that number of open and close are. Let's look at another example. Let's see. Wait. I'm going wrong, man. Yeah. Is this a valid parenthesis? It has equal number of open and close parentheses, but still it is not a valid parenthesis, right? Why is it not a valid parenthesis? Now here comes another logic, that is each of the closing parentheses should should have an open parenthesis. So basically, a close parenthesis should follow only after there is a open parenthesis for that one only. Here it is wrong because only because, see, basically if you look at this one, this parenthesis, this is a closing parenthesis, right? So the corresponding open parenthesis for this one is this one, right? But this open parenthesis do not have a closing parenthesis. That is one thing. And this closing parenthesis do not have a open parenthesis, right? So that is the problem here. Now, how to always ensure that all the opening parenthesis has a closing, like all the closing parenthesis has their opening parenthesis becoming before them. This is something we have to ensure. So let's like think about it. If we like count every time, like we have a kind of iteration. Yeah, let's have a kind of iteration where every time we increase, like iteration, like yeah, every time we increase open parenthesis, yeah, open ones we can do, open parenthesis by 1. And should we also do close parenthesis also? Yeah, we should also increase close parenthesis every time we increase close pairs also. But here we have to remember a condition, that is, see, a close parenthesis can only come after it has an open parenthesis for it. So in any consideration at a particular point, we cannot have more close parenthesis than open parenthesis. So the only thing is we need to remember is number of close parenthesis at an iteration should always be less than number of open parentheses. So this is the only major like uh, condition that we have regarding this close parenthesis part. Now, yeah, this is it. Now, like let's think about the corner case. Like till how much should we keep increasing these parentheses for constructing a string? So, yeah, the corner case would be until we have like what can I say? Until we have like uh, n open and like we just need to think about n open, because once there are n open parentheses, we can just have rest of the like close parentheses only. Okay, we cannot no longer have any more open parentheses, right? So yeah, until we hit this one, corner cases, until we hit n open parentheses. That's it. That's it. Yeah, that's it. So basically, so what I'm planning is like, let's make it kind of a recursion, and in every step we are going to increase the open parenthesis by 1, close parenthesis we are going to increase by 1 only if the number of close parentheses are already less than the number of open parentheses, and we need to continue this until we hit n open parentheses. After n open parentheses, we are going to fill all the rest of the like whatever left in our string with close parentheses only. So that's it. Yeah, let's jump to the coding part for this. Yeah, let me clear this right now, and we can jump to the code. What's it, man? Yes. So we have this function called generate parentheses. Now let me create a function, vector. Do we need a vector, or let us create a void function? Yeah, that is good. Hey, like I'm comfortable with Python and JavaScript also. If you need the solution in any other language, let me know. Yeah, and Java also. Yeah, let me know. I will try to do them on as well. But this is going to be a C++ solution only. So yeah, let's make it uh, compute combinations, and yeah, that's it. And what we take in the input, open, yeah, we take the number of open parentheses, take the number of close parentheses with a n, and we need a vector basically to store the outcomes, like vector string uh, outcomes, to store all the outcomes that are possible, and we will finally return these outcomes. Yeah, outcomes. Yes. So in each step we first check if open is equal to n. Yeah, then we come here and return. We will write this logic in some time, what we do. Yeah, now let's come here. What we do here is compute. Yes, that's it. Okay, we need to store the string somewhere in here, right? String s. Hmm. So what we do is compute combinations open plus 1. So we increment open by 1. Yeah, and if we increase open by 1, what we need to do is add open parenthesis to s, n remains n as well. So yeah, this is going to be vector outcome. Let's complete this string. uh, yeah, we are going to change it, so outcomes. Yes, that's it. We are going to pass this in here, and if close is less than open, only in case of close is less than open, we basically just repeat this one with incrementing close instead of open. So it looks like this. We need a plus 1 in here, close plus 1, and the string gets a closing parenthesis. That's it. Finally, what we do is we return it. Yeah, and let's now come down to here, come up to here. If we have exhausted like all our opens and we can just fill the rest of the outcome with closing parenthesis, then what we do is while close less than n, s plus equal to closing parenthesis, yeah, and we just push it into outcomes, push back s. Yes, that's it. We need to all to increment close plus plus. Yeah, that's it. I think what we need to do now is we need to call this function in here so that our outcomes get generated. Zero, close is also zero at the beginning. Let's have a variable for s, string s equal to empty string. Seems good. So we have s, then we have n, and we are directly getting, then we have outcomes. Yeah, that's it. Looks pretty good, right? Let me run this in here. Yeah, this is working, right? Let's submit this. Hey guys, this feels so good, man. When you get this, yeah. Although this is a simple problem, but still, it feels good. Yeah. What are topics? It's related to dynamic programming. We did not use dynamic programming. We just used recursion, right? Yeah. Can we do it? How can we do it with in a for loop? I was thinking. Yeah, let me think about that. How can we use something like a loop, iterative way? Yeah. So yeah, that was pretty much this problem today. Uh, I will I will come up with some other interesting problem next time. Yeah, that's it. Thank you guys. Like, share, and subscribe this channel. Yeah, and I am looking forward to see you guys in the next session. Bye.